Assalamualaikum warahmatullahi ta'ala wabarakatuh and good day to each and everyone. So for today's videos, we will continue our previous topics regarding on these line integrals. Okay. So once again, no, I just reminding you, no, I'm just actually reminding you that please print out your own copy of these manuals or instructional materials for us to be able to follow or to serve as our guides, okay, throughout our discussion. And of course, uh, kindly use your own headset uh, to fully or clearly understand this discussion, okay. So now, continuing our discussion, so if you remind, no, if you uh, uh, if we okay, recall that from our previous discussion, okay, um a line integral, okay, or an integral that is being integrated on some path, no, with respect to some path, is actually related from the integral, no, which we are familiar with in our previous mathematics, no, in which this is the definite integrals, okay. But only difference is that the definite integrals that we are familiar with is that it is being integrated on the x-axis only, no, with respect to x-axis only. So in this line integral, we are integrating some function, okay, with respect to some curve, okay, with respect to some curve, okay. So we have here other forms of line integrals, no, as you can see here. So last meeting natin, okay, we learn that a line integrals is being performed using equation number 3. So pakitingnan na lang, okay? Equation number 3. That is the application of a dot product of a function, no? Vector function at saka yung kuan natin, path natin or yung lines natin, okay? So then after nung dot product na yon, so i-evaluate natin sila using the limits, okay? So after that, the final answer is the answers of or the results of line integral, okay? So in this case, no, we are having the simplification of that line integrals, no, by using its components, no, or by uh, okay, by not um using the dot product, okay, that we have already discussed previously, okay. In this case, no, the line integrals from equation 3 is also can be written as this equation, no, can also be written as this equation 7. We have here f1 dx um at some curve c, okay, and f2 dy at some curve c, or f3 dz at some curve c, provided that your f, no, na function mo is equals to f1i or f2j or f3k. Sorry. So in here, no, we obtain the line integral whose value is vector rather than scalar, no. Ang advantage ng ganitong approach is that, okay, the result that we have get is, or okay, the resulting value, no, from the solving or from this line integrals is actually a vector, unlike sa kanina na scalar, okay, yung results natin kasi 'di ba nga yung 'di ba nga, no, yung dot product ng isang dalawang vectors is also is actually a scalar quantity. So in this case, magiging vector na siya actually, so including na actually yung kanyang direction, no. Okay. So example tayo, we have here a line integral of the form 8, no? We have here integrate f of r x, y, z, and z along the helix in example 2. So this is actually from example 2. Pakitingnan na lang yun siya. Okay? So we have here the solution. We have f of r of t is equals to cosine of t sine of t, 3t sine of t, and 3t, no, from our previous discussion, from our previous examples. So we have here integrated with respect to t from 0 to 2 pi gives this one. We have here f of r, f of r of t dt. So ang gagawin na lang natin is a substitute natin, no, or i-integrate natin by parts itong integrates natin, no, uh, integrates natin individual itong cosine t sin t, tsaka nitong 3t sin t, at saka nitong 3t. So, individually. So, the result is itong negative 1 half cosine squared of t, tapos 3 sin t, tapos negative 3 sin t minus 3t cosine t, at saka 3 over 2 t squared. Okay? So, yan yung result ng individually na pag-integrate dito sa cosine t sin t, 3t sin t, at saka 3t. Okay? So, tapos evaluate natin sila from 0 to 2 pi, isa-substitute natin yung from 2 pi to 0. So the result is 0, negative 6 pi, at saka 6 pi squared. So as you can see here, no, this is actually a vector, no? May component siya sa ijk. So ibig sabihin, vector siya. So kung titingnan natin yung example number 2, the result is actually a scalar, no? So ibig sabihin, hindi siya expressed in this way. But take note that, no, parehas lang sila. Okay, it just that itong result na to is naging vector kasi including yung kanyang direction. Doon sa example number 2, wala or scalar quantity lang siya. So, ibig sabihin, hindi na included doon yung kanyang direction. Okay? So, pero parehas pa rin din sila. Take note of that. It just that iba yung approach na ginamit to solve the line integral. Okay? So, we have here 1.3. We have path dependence, no? The line integral 3 generally depends not only on f and on endpoints a and b of the path, but also on the path itself along which the integral is taken. Okay? So, uh, so understandable naman yun siya, no? Pakibasa na lang. So, we have number 2 here. We have path independence of line integral. So, kung yung kanina is path dependence, dito is path independence. Okay? Ibig sabihin nito, when we are integrating some function, okay? When we are integrating some function with respect to some curve, okay? Uh, that function or that result is not dependent with any path, no? Which will make, no, from starting point to the end point, even if you are not, or even if that path is not the same direction with the previous path na nagamit. Okay? So, ibig sabihin nun, magkaparehas pa rin ng result, okay, ng pag-integrate mo sa isang function with respect to path, okay, kahit saan ka man dumaan, as long as, okay, as long as nag-start ka in the same point and then nag-end ka in the same point. Okay? So, makikita natin siya dito. Okay? So, as you can see here, okay, kung babasahin natin yung graph na to, yun yung ibig sabihin. At saka yung graph natin is same as I have said kanina, no? As you can see here, okay, even you are going from A to B, even if your path is not the same with the other one, as long as your point is the same, no? Your starting point is the same with your the same, at saka yung endpoints mo is the same, ganun pa rin yung result mo. Okay, so hindi pa rin mag-iiba. Kahit hindi dito ka man magdaan, dito ka magdaan, dito ka magdaan, or ganun. So, the same pa rin yung results. Okay, so yan yung tinatawag na path independence. Okay, so we have here theorem 3. So, kuha na lang to, ha. Okay, sa manuals ninyo, dapat path independence to siya, hindi path dependence. Okay, so theorem 3, we have path independence. Sabi dito, okay, masasabi mo na yung function mo is a path dependence if and only if, okay, yung f mo na yon na i-integrate mo, okay, um, at some with respect to some path is equal to gradient of some function f na small letter f. Okay, so ibig sabihin nun, no, if your f1, no, which is the component of your f here na naka-boldface, no, if your f1 is equals to partial of f with respect to x, okay, and your f2 is equals to partial of f with respect to y, and your f3 is equals to partial of f with respect to z, okay, ibig sabihin nun, your f is path dependence. Okay, once again, okay, masasabi lang natin na yung f natin, yung function natin na integrate natin is path dependence if and only if masasatisfy mo itong f1 is equals to partial of f with respect to x, f2 is equals to partial of f with respect to y, and f3 is equals to partial of y, partial of f with respect to z. Okay? So, yun yung ibig sabihin ng f is equals to grad f. Okay? So, example number 5, we have path independence. So, show that integral f dot dr which is equals to 2x dy which is equals to 2x dx, 2y dy, 4z dz are integrated with respect to curve C is path independent in any domain in space, okay, and find its value, no, if it is path independent, find its value in the integration from a which is equals to 0, 0, 0 starting point at saka to b which is equals to 2, 2, 2 which is the end points. Okay, so we have here the solution. We have f is equals to, as you can see here, we have f is equals to 2x, 2y, and 4z. Okay, now i-check natin, no, malalaman natin na path independent siya if masasatisfy natin yung kaninang sinabi ko na grad f, no? Okay, so yung gradient f natin. So as you can see here, small letter f natin is equals to x squared plus y squared plus 2z squared. So saan yung nagmula? Okay? So nagmula yan siya sa original function natin. Okay, itong f is equals to 2x, 2y, 2z. Bakit? Kasi kung i-derive mo itong x squared natin, no? Kung i-derive mo yan siya, magiging 2x. Yung y squared natin magiging 2y. At saka yung 2z squared natin is magiging 4z. Kaya here, 4z. Okay, so that's why satisfied na yung kanina natin, no? Yung kaninang sinabi ko na partial of f with respect to x is equals to 2x, no? As you can see here, kung i-derive mo itong x squared na to kasi yan man yung f natin, no, with respect to x, so magiging 2x lang, tapos ito siya is 0 lahat, tapos partial of f with respect to y is 2y, no, kasi kung i-derive natin itong f, small letter f natin with respect to y, 0 itong x squared, 0 itong 2z squared, so mangyayari is 2y lang yung result. Then partial of f with respect to z, kung i-derive natin to siya, itong small letter f natin with respect to z, ang mangyayari is 4z. Okay? Therefore, satisfied na yung kuan natin. Satisfied na yung um, uh, condition natin. So, ibig sabihin nun, itong integral na to is path independent. Okay. Now, what is the advantage, no, of having path independent, no? So, kung yung function mo is path independent, okay, pwede mong directly i-substitute yung point mo, no, na given at, okay, yung starting point mo na given at saka yung starting end mo na given to have the final answer. Okay? So as you can see here, no, the final answer of this integration, even without the integrating or limit of integration, no, the value of this one is found by just substituting this point A here at saka itong point B dito kay small letter f, okay? Yung result ng gradient ng big letter f natin. So, we have here, tapos i-minus natin, tapos ang magiging result is yun na yung result ng integration na to. Okay? Now, if you are performing this integration here using a normal way or yung way natin sa previous natin na discussion, okay? Kagaya dito, no? Sabi dito, if you want to check this, use the most convenient path, no? Which is equals to t, okay? Si r of t or path r of t is equals to t, okay? From 0 to 2, okay? You will get also 16, okay? But only the difference of this one, no? Kung tatanungin ko kayo, no? sino yung mas madali rito? Mas madali ito siya, itong path independent na assumption, no? Kasi ang gagawin mo lang is isa-substitute mo lang itong A at saka itong B dito kay small letter f. Tapos ima-minus mo. So, yun na yung result. Pero dito, magpe-perform ka pa dito ng dot product tapos i-integrate mo pa, no? So, mahirap pang integrate siya kasi may mga path ka pa dito na susundan, okay? So, mahihirapan ka pa, okay? So, that's why in here, suggestible talaga itong path independent, okay? So, yun. Okay, so we have here 2.1. Path independent and integration around closed curve. Okay, now, if your graph or if your function is path independence, no, and then if you integrate that one, okay, with respect to some closed curve, the result will be equal to 0. Okay, so that is one of the characteristic of a function where it is path independence. So, dapat yung integration niya with respect to the closed curve is equals to 0. Okay? So, pakibasa na lang tong where conservative and non-conservative, just the discussion of this one here sa path independence of the closed curve. Okay? So, we have here path independence and exactness of differential form. So, the same lang to siya sa kanina, yung gradients natin, no? As you can see here, yung function mo daw na f, which is equals to f1, f2, and f3, okay? At saka yung integration niya with respect to some path na r, that is equals to f dot dr or f dot product with dr is equals to f1 dx plus f2 dy plus f3 dz is differential or is independence, no, path independence if and only if it has a differential form of this if it has a differential form of this kind of equation here, we have here df is equals to partial of f with respect to x dx plus partial of f with respect to y dy plus partial of f with respect to z dz, or equals to grad f or gradient f dot dr. Okay, so yun na ibig sabihin yan. So ibig sabihin nun exact yung ibig sabihin nun uh, if our function is a path independence, ibig sabihin it is exact, no? It will satisfy this equation. Okay? Masasatisfy niya itong equation na to. Okay? So, okay, so we have here an example. I mean, okay, we have here different theorem 5 at saka theorem 6. Pakibasa na lang, okay? So, itong example number 6 just talks about, okay, the differential form of this function natin dito na 2xyz squared, x squared z squared plus z cosine of yz, tsaka 2x squared yz plus y cosine of yz, no? In here, no, as you can see here, um, wala siyang binigay rito na integrating limit. So, that's why, okay, ang magagawa natin dito is that to check if this function here is path independent or not, no? To check that one, so we have to perform this one, okay? So, as you can see here, no, exact naman siya. So, therefore, pwede na nating sabihin that it is a path dependence, okay? So that's why in here, ito yung final answer natin when we are integrating this one. We have here f of xyz equals to x squared yz squared plus sine of yz. Tapos since it is path independence using our uh, exactness of differential equation. Okay? So it is path independence. Ibig sabihin nun, we can directly substitute the uh, starting point which is A, 0, 0, 1 at saka yung ending point which is 1, pi over 4 at saka 2. Okay? Then after that, subtracting that one, so the result is the final answer of this integration here. Okay? So you have here pi plus 1. Okay? So if you have any question about this discussion, okay? kung may mga hindi kayo naintindihan, okay, you may just have to ask it to me, okay? Or you may just to consult it to me physically, no? Sa campus, okay? So inshallah, we will try to discuss it further, okay? So that's all. Assalamu alaikum warahmatullahi wabarakatuh.